So we're going to look at how different fractions can be equal to one another. Okay, so there's something called equivalent fractions. So we can look at a 3/5 fraction. So if we see here, the part is the three pieces shaded. The whole is going to be this whole thing here. Okay, and I'll just draw in, okay, so you can see that there's 5 parts that make up the whole. So this is our fraction. We can make another fraction that is equivalent to this one. Okay, it has equal value. So if we take a look on the number line, we'll have an equal position on the number line right here. Okay, so this is our 3/5 fraction, and we can show that there are many other fractions that will end up in the same spot. Okay, so we can look at an equivalent fraction, and I'll give you an example. We can have 6 parts to 10 parts whole. Okay, well, that means then that I have to first of all divide this into 10 parts. So notice that I'm just going to double the number of pieces. So there's the double number of pieces, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 pieces that make up the whole, and I want 6 of those pieces. Okay, so I want this piece, 2, 3, 4, 5, 6, and we can see that those 6 parts end up in the same position. Okay, although this fraction is slightly different. Okay, 3 to 5, 6 to 10, the ratio or proportion is exactly the same, and it ends up in the exact same point on the number line. So they are equivalent numerically to each other, the same number. Okay, they're the same decimal when you divide it, and they're an equivalent proportion. Okay, and you may have noticed that, well, when I drew out the parts that make up the whole, I did it times 2. I just doubled the number of parts that make up the whole. And notice that what also happened in the numerator. Okay, I have 3 parts to 6 parts. Well, I just doubled the number of pieces that make up my numerator. Okay, and this is how ratios work. We know that these are proportionally the same because if we scale the numerator the same as we do the denominator, we have the same ratio of parts to whole. Okay, and we end up with the exact same numerical value. Although it's in different proportions, they are proportionally the same. And we could do the same thing, and we could just, divide it even more. In fact, I can write this as 9 pieces out of 15 parts whole. Okay, so what I need to do is I'm just going to start with my fifths here, and I can divide these into 3 parts. Okay, so I know I need 5. If going from 5 to 15, I need to increase by 3 times. So I show 3 parts. Okay, so I do 3 more divisions inside each one of those parts, or 3 groups of 5. And I can do the same thing with my shading. Instead of having one piece shaded, I can shade 3 parts. Okay, one piece shaded goes to 3 parts. One piece shaded goes to 3 parts. So my multiplier was times 3 for the top, times 3 for the bottom. And that proportion, since it's multiplying the same on the top and bottom, is proportionally the same. So these are equivalent fractions. This is how fractions and ratios work. Okay, they work with times and divide. If I could multiply and do groups of the same on the top and the bottom, we're talking about the same proportion or the same fraction. Okay, and we can see that numerically on the number line, they are exactly the same, right? So here's our number line. So they are numerically the same, they're proportionally the same. They're the same number, and they're the same proportion, although they use different terms, 3 to 5, 6 to 10, 9 to 15. These are what we call equivalent fractions because they are, again, proportionally the same. So why are the equivalent fractions using this idea of part whole? Okay, so these are the same as part whole because we have the same proportion of parts to whole. Okay. On the number line, they're on the same spot. All are on the same place on the number line. Okay, so it's the same. And as a percentage, if we actually divide these, work out the percentage, this would be 60%, 60%, 60%. So even as a percentage, the percentage works, and I'm going to say not just the percentage, the decimal, percentage or decimal, is the same when we divide. Okay, so these are important concepts, and the main idea is this idea of proportion. If we have proportions that are the same, the fractions can be said that they are the same.